G'day, hello everybody. Brian here from quantlabs.net. Again, another video here. Just wanted to let you know this one generated another video comment regarding meta programming related around Rust. And this comment was it may have no runtime overhead. This is meta programming on C++, but man, template meta programming always comes with so much mental overhead from C++'s terrible diagnostic messaging and the lack of support for templated code from LSP, linter, static analysis tools, and the like. And then it also increases the build time by a significant amount. Now, when you go to my blog, in the description, you'll see here I've got some references that you can take a look at to understand what I mean. And why am I making this video? Is quite simply because don't be surprised that a lot of high frequency trading shops is using this technique to be able to uh, develop pretty well, very quick trading systems using this style of programming. It's one of the only languages out there that can do this is C++. Again, template, metaprogramming, double-edged sword. So it's a powerful C++ technique that allows programmers to perform computations at compile time. So there you go. That's another secret sauce message that I think a lot of trading shops are using. Leveraging C++ templates, some system developers can generate highly optimized code because the compiler does it when it converts it from or compiles it from C++ into assembler. Uh, Optimized code for after often outperforming handwritten code. However, TMP, template metaprogramming, comes with a significant cost at steep learning curve and substantial development overhead. So take a look at those links I put at the bottom of this article. You can find that in the blog. TMP allure lies in its ability to generate specialized code tailored to specific input type at compile time. This can lead to significant performance improvements as the compiler can optimize the generated code more effectively. And again, that's put in further into assembler. TMP can be used to implement complex algorithms and data structures that would be difficult or impossible to implement using traditional C++ techniques. So again, you can see the secret sauce being peeled back here with this type of technique. Again, take a look at those articles I put at the bottom. TMP can be used to implement compile time type traits, which can be used to query information about types at compile time. Info can be used to generate specialized code based on the type of input. So again, the type of input we're looking at is maybe market data, and then using some kind of algorithm built into the template programming, then be able to output signals and then output trades from that. That's what I'm thinking. Now, out there in the world of YouTube, I'm sure there's going to be people commenting on this. And that's basically one of the other crust of how this can be done in C++. There's some tips here on how to do it as well. TMP can be also used to implement compile time loops. Wow, that's pretty impressive. Can be used for to perform computations at compile time. Can be useful for such as generating lookup tables or performing mathematical calculations. Does that not sound like what HF2 requires and needs? Of course it does. Now here's the challenges. Presents a number of challenges. One of the most significant is a steep learning curve. Okay, now you know why these folks in these HFT trading shops are being paid millions of dollars. So TMP requires deep understanding of C++ templates, which can be complex and confusing topic. Even experienced C++ programmers may struggle to master TMP. So look, if you're seeing a bunch of bozos on YouTube going on about this stuff, about HFT, this is one of the techniques used. And I highly doubt they're probably at best okay at marketing, but what they're blowing out is just, you know what I'm saying, right? Another challenge is the lack of support for templated code from LSPs linters, static analysis tools, and other development tools. It can make it difficult to write and debug templated code. For example, many IDEs can't, and code editors have limited support for these templates. Make it difficult to navigate and understand templated code. Many static analysis tools are unable to analyze templated code, which can lead to bugs that are been there, done that, hard to discover at runtime. Most significant challenge of TMP is the impact on build times. So I've worked on coding projects that could take a couple hours to compile. So if you put one little problem in there and then you find it, then you have to recompile and wait another more a couple hours to build it. C++ compilers must process templated code at compiled time, which can significantly increase build time, especially for large projects with many templates. So again, this is one of the tips you'll hear about. This can make the development process slower and more frustrating. Now, there's a lot of mental anguish that comes out of this. TMP also imposes significant mental overhead. C++ template errors and can be cryptic and often difficult to understand, often requiring a deep dive into the template code to identify the root cause. This can be a time-consuming and frustrating process. So, as you heard in the comment, this is what this person is referring to. TMP can be powerful, but it's important to weigh the benefits against the cost. Performance benefits. TMP may not justify the increased development time and complexity. So here's some solutions. Start small, simple meta template program. Gradually increase the complexity as you gain experience. Use clear and concise template code. Avoid unnecessary template parameters and complex template expressions. Leverage existing libraries. Many C++ provide template programming facilities that can be used to simplify development. One key ingredient I will tell you about HFT shops, because I'm getting it from the insiders over the years. They don't develop their own third-party or use any open source libraries in C++. They develop their own. As they develop them, and again, they're not going to let you, me, or anywhere else know about these libraries because they're using it for their own needs, and it'll never be released to anybody. This is part of their secret sauce magic set of tools that they have. Modern C++ features. So again, we're now moving into past the version 17, 20, 23, now upcoming 26. These are the sort of things that the U.S. government's going on about how C++ can be dangerous because you're allocating your own memory. So here, if you're using the built-in features, this might make life easier. C++ feature such as concepts, const expression. If you read that book that I've got here that you can get at the Learn tab at quantlabsnet.com, here, if you sign up, you'll be able to get that book to understand one of those principles. There are many things that I go on and on about. Let me just go back to where I was, if I can get my tray. Okay, there we go. There we go. Yay. Okay. Test thoroughly, write comprehensive unit tests to ensure that your templated code is correct. Again, that's a no-brainer. Consider alternatives. In some cases, it may be possible to achieve the same performance benefits using other techniques. Again, now this is all the neat things you can do with C++. Expression templates or loop unrolling. What? I've never heard of this stuff. Allowing these programmer practice developers can harness the power of TMP while minimizing the associated costs. And again, as I said, if you go to that blog post, you'll get more resources there to learn more. And it looks like there's a book there as well from Pact here, how to build metaprogramming TMP using tutorials. That's about it. Again, if you want to know more, know what I'm doing, come over to the quantlabsnet.com. Under Learn tab, take you there to get the ebook that I just mentioned. Also, there's a forum here that we've opened up last week as well to talk fancy pants stuff on tech and trading related. Thanks for watching. Have a good day.